So the second part that we're going to talk about is the maintenance test. Maintenance test can be applied for the cables, and it can also apply to the switchgears and the transformers. So in this part, we're not going to talk about too much about the equipment. We're going to use the same equipment as we talk about in the commissioning test, but we're going to talk about the sensors that we can use, and we'll have some case studies to explain. Let's see. So the maintenance test, here the purpose of the maintenance test, so basically is just to ensure the equipment in the service condition are still in good condition, and they can still remain in the operation condition, and there's no unplanned outage occur, or there's no premature failure that may occur. So the maintenance test, in general, we can split them into the online and offline test. And offline test is very similar as commissioning test. The difference of the maintenance test and the commissioning test, if we're talking about offline, is the testing voltage. So if we're using cable as an example, for medium voltage cables, commissioning test, maybe the testing voltage can be 2 to 3 times of the operating voltage. And in the maintenance test, probably we want to limit them under two times of operating voltage. In most of the time, it will be 1.5 to 1.8 of the operating voltage for the maintenance test. Again, the operational procedure will be the same. The data interpretation will be the same. For online tests, it will be quite different. So we're going to talk about online test here, and we're going to explain why online test is a preferred method for the maintenance test. So online test, a couple of advantages. So they're all listed here. I think it's quite obvious. So first, online test, we don't need to switch. We don't need to put the equipment on the test to be offline. So that's economic. We don't need to interrupt the production. We don't need to have additional operation to do the switching on, switch off. Yeah, and also online test is a real non-destructive test, and there's no overvoltage at all. The equipment on the test is operating in its normal condition, and because there's no overvoltage applied, so the online test will not activate any dormant PD sites. And also, since there's no switching, so the switching transient could be 3 or even 5 times higher than the operating voltage. So since online testing, there's no switching, so we can also avoid the switching transient. So that's the big advantage of online testing. It's really non-destructive. And some other advantage of online testing include the testing efficiency is pretty good compared with offline test, because apparently we don't need to switch off, and we don't need to use external power supply to do the test. And also, if we're talking about safety, because online test, everything is operating in its normal condition. There's no external power supply, and there's no disconnection. So the operational safety compared with offline test, it's a plus. And also the completeness. If we compare online with offline apparently we only test the equipment on the test, which is switched off from the grid. And online test, we test everything that are connected to the equipment on the test. So using cable as an example, cable is connected to the switchgear or connected to the transformer, and when we do the online test, all the connected equipment, if they have problem, we're going to see it. So this is an advantage, and also it's a disadvantage. The advantage is we can see a lot of things even out of the testing scope. The disadvantage is there are so many things connected to the cable system. So we need to have a very good tool knowledge to distinguish these signals from different sources. The PD fundamental part, we explained how we can do the source location. There are 4 methods that we can use to locate which device or what part of the circuit gives us such a signal. So let's talk about sensors for different applications. So in general, the sensors are similar as commissioning test, except for some specific applications. Like if we're talking about cables, the very common sensors for the cable testing, HFCT, as I said, this is the most common sensor that we use for commissioning test and also the maintenance test. The UCAP sensor very helpful for the online testing, including cables or transformers or motors, as well as we have access to the cables. So UCAP sensor, we just put it on the shielded part of the cable. If there's any signals, PD signals in the connected part or within the cable system, it can be captured by the UCAP sensor. So the operation is also quite safe. We operate by a hot stick. So the operator can be 6 feet apart, 6 feet away from the energized part. And for the transformer test, we still have the HFCTs, and there's one specific sensor for the transformer testing, the tap adapter. So the tap adapter, very powerful sensor that's installed in the transformer bushing tap. Installation itself might be a challenge. Some transformers probably we don't have access to that, but once we have it, it can give us a lot of useful readings. This, by the way, this is also the recommended sensor that we use for the transformer monitoring solutions. So the tap adapter, the benefit of using the tap adapter is first, it can measure partial discharge, of course. Second, because it's tap adapter, it can measure the capacitance of the bushing. So it can monitor the change of capacitance of the bushing. And the third, using the capacitance value and the measured voltage value within the bushing, it can also measure the change of 10 delta, the dielectric loss of the bushing. So the tap adapter itself can measure 3 values: partial discharge, capacitance, and the dielectric loss. So those are the diagnostic markers that we were being talking about. We can have different diagnostic markers for transformers with the tap adapter. And for the switchgears, HFCT again, this is common sensor, and besides that, we can use the TEV, transient earth voltage jumper, that can be installed on the door of the switchgears. So we don't need to open the switchgear door. In many cases, for the safety concerns, the customers don't want to open the switchgear panels. TEV jumper will be a good choice. So here, one case study of using the TEV sensors. I mean, the HFCT and other sensors are similar as commissioning test, so we're not going to talk too much about that. The TEV jumper is a good example, as we talked about. There's a row of switchgear panels, and we use the TEV jumper to test each individual of them. So this is some equipment setup. This is the testing result. We test all the panels with the TEV sensor, and there are 4 tests. So the customer is cooperating to switch the load on and switch the load off. And some tested the load is it's half. Some tested the load is 10%. So that's the reason we have 4 tests. And with all the tests, and the test 1 was the no load. The incoming is switched off. So if we have the load, and all the points shows that the incoming panel has the highest value, and this is the measured phase result pattern. So we kind of allocate the problem is within the incoming switchgear panel, and of course the customer open the switchgear panel and find out, hey, this is the problem. So again, TEV sensor, if we only use the TEV to measure a single switchgear cubicle, if there's only one single switchgear cubicle, of course that would be effective. But if we have a row of switchgear cubicle, it's always recommended to take multiple readings, put the sensor at different location of the panel, measure all the panels, and do the comparison. That will give us the best diagnosis result to tell which component is the defective component. Another case study for the maintenance test. So this is a little bit interesting. It's a wind farm, inland wind farm application. The customer experienced a few failures in the cable, 35 kV XLPE cables. The cable is very long. It has a couple of junction boxes. And the customer wants to monitor that cable, the entire cable. So we suggested that we can install the HFCTs permanently on multiple locations in the cable. So as we said, the cable is about 5 miles long. So it's about 5 miles, it's about 8 kilometers long, a little bit longer than 8 kilometers long. And we put HFCT sensors on 5 locations, from the termination in a substation and some junction boxes along the cable length. So we put HFCT sensor on each individual phase, and the HFCT sensors are coming out and connected to a we call it derivation box, which is more like a connection box. Yeah, the derivation box itself provides the connection to the sensor, and also it has a protection circuit inside. So since we're doing online testing, or maybe we're doing, it opens the opportunity to do the permanent monitoring. So if we're talking about a permanent monitoring, of course, we need to protect the equipment, the testing equipment. So the derivation box itself has the protection circuit. So here are some examples of the permanent sensors installed for that circuit. In the substation end, very easy installation. We have a outdoor box to protect the derivation box. And derivation box, it provides 6 channels with a sync channel. Sync channel, we use a low frequency CT, put it around the cable to get the 50 or 60 hertz signal for the synchronization. And in the cable run, the customer put some connection box or junction boxes, and also we put HFCT around the ground wire and the low frequency CT around the cable to get the sync. So the configuration is about the same. Some junction boxes, we have 6 channels to measure cables going into both directions. So this is the permanent sensor installation. It's a midway, or it's one step above the periodic maintenance test. So instead of sending people to test every year or every other year, once we have the permanent sensor installed, the circuit owner, they can do the test by themselves. Because the access is quite simple and quite safe. Technically, they can do the test anytime when they feel it's necessary, or they can set up a testing plan. For example, if they want to test every month or every 2 months, and they can build up a solid trending data for that circuit. And once there's any change in the circuit, it should be very effective to show in the trending analysis.